Hello everyone, on behalf of the Department of Mechanical Engineering at San Jose State University, we are presenting the Trash Compactor, which will soon go into the consumer market. I'm Antonio Gonzalez.
My name is Luis Aguilar.
I'm Tong Chi Chen.
I'm Charles Wiseman.
The main motivation of our project is inspired by the overfilled trash bins around the city areas of San Jose. Common trash that has a hollow construction such as coffee cups and phone boxes were thrown into the trash bin, which filled the trash bin very fast while having relatively small weight. The same problem can also be found in indoor areas such as an office or a kitchen. The overflowed trash bins not only create a negative environment but also increase the frequency of replacing the trash bags. Our project will be focused on the indoor problems. Although similar products currently exist on the market, they are often very expensive or very hard to use. For example, some of the compacted trash bins require the user to compact the trash with their upper body strength while bending down, which can be difficult to operate for children and elderly. Therefore, a new design that is more affordable and easy to use is necessary. A solution to this problem is to borrow the concept from industrial trash compactors and shrink them into a household-sized compactor bin.
A house of quality was used to ensure customer satisfaction by relating customer desires with design specifications. Various requirements were rated by their relative importance to the end user, the product's marketability, and the manufacturer. Effectiveness, cheapness, and ease of cleaning were deemed the most important to the end user, marketability, and manufacturer, respectively. The user requirements were also related to measurable engineering specifications, including the height, the force required to operate, and the price. The relationship between each user requirement and engineering specification was rated as having either a strong relationship, medium relationship, weak relationship, or no relationship at all. The engineering requirements were rated to each other on the same scale. Competitors' products were rated by their ability to meet the user requirements. Their design specifications were also found. Finally, we created a set of target design specifications for our own product, meaning these targets would make a trash compactor that is better than any of our competitors.
This is a finished model of the trash compactor. It is suitable for both kitchen and personal waste. For operation, the user will open the lid and place their trash into the bin. Next, they will close the lid and lock it with the latch. Once the lid is secured, the user can step down on the pedal, which will mechanically lift an inner bin with the assistance of 6 pulleys. This results in compacting the excess trash against the lid. The user can then release the pedal, which will be drawn back to its original position due to 2 extension springs located in the back part of the bin.
The lid, the springs, and the bearing axle were 3 critical parts in the design that were subjected to stress analysis using CAD software and calculations. The lid showed a minimal stress of 0 psi due to a maximum pressure of 0.35 psi, which is what it would take for the trash to get compressed. Due to the low stresses, the lid had a factor of safety of 4.3 times 10 to the 4th. This shows that the lid will be very reliable in the design. The springs were subjected to dynamic forces between 0.78 and 6.46 pounds. Using stress analysis calculations, the factor of safety for the spring came out to be 1.33. The last critical part consisted of the bearing shafts for the pulleys. Due to the trash compactor design, the bearing shaft would be under a maximum torque of 40.625 pound-force-inch and a maximum force of 32.5 pounds. Under these loading conditions, the analysis showed a deflection bearing between 3.95 times 10 to the negative 2 inches and 5.6 times 10 to the negative 4th inches, which is minimal and acceptable. The factor of safety for the bearing shaft yielded a result of 4.2. Based on the stress analysis for the 3 critical components, there shouldn't be any concerns of failure during the lifetime of the product.